So recently I did a video comparing the Python sorting algorithm, and this was comparing the M1 MacBook Air to a Ryzen 9 machine to see who is faster. And a lot of folks in the comments said, well, why aren't you using some kind of sorting algorithm that's implemented in Python? Well, Numpy is a pretty popular Python library that's an add-on, and why wouldn't you use it? I guess the argument goes saying that if it's implemented in Python, then it might be faster, but that's not the case. Let me show you what I mean here. Here's what I showed in the video, okay? There's 100 million items that we're sorting, and we're using Numpy, import Numpy. We generate 100 million random items from 1 to 100 million, or from 0 to 100 million. I don't know which one it does. And then we hold that in an array. We start the counter, we do the sort, and then we end the counter. And then at the end, we print out how long that sort took. We're using the stable sort, and somebody suggested, why don't you try timsort? Timsort is a sorting algorithm based on merge sort and insertion sort that's actually really fast, and it's considered a stable sort. And stable sorting is preferred over non-stable sorting because stable sorting keeps sequences of same numbers in the same order that they were originally in the original unsorted list, and that's actually preferable. Anyway, you can look up what stable sort means. So let's run this and let's see what happens. I'm gonna time this, and we got Python PySort, and there we go. So this will use Numpy to give us a result, and then what I'm gonna do is I'm going to try timsort. Okay, now we've got a result. It took about 11 seconds. Okay, good to go. So 100 million items took about 11 seconds to sort. That's actually pretty good. So I got timsort, the algorithm in Python, right over here. I'm gonna link the repo in the description if you're curious to check this out yourself. But I'm gonna import this as a module into my PySort script here so that we can run the same code on it. I'm gonna say from timsort, import timsort, that function that actually does the sort, which is this one. So we need to pass it an array. We happen to have an array, but this is a Numpy array or data set, whatever they call it. I don't know. So we need to convert that to just a regular Python list first. So let's do that down here. I'm gonna make a little separation. I'm gonna create a new list, and I'm gonna take our data that's generated by Numpy. I'm gonna convert that to list. It has a convenient little toList function. There we go. And now all I gotta do is say timsort and pass in that list. So it's gonna sort it in place. And just like before, we're gonna get our little perf counters. Let's get that one before the sorting starts and after the sorting ends. And then we're just gonna print out how long that took. So timsort in that many seconds. Folks, I think we're ready to run this. Control backtick in Visual Studio Code to open up the terminal, and let's go. Okay, just as before, we're around the 11-second mark with Numpy sort. And now we just gotta wait for timsort to finish. This is one of those times when a Python song would be handy to have.
We don't like marathons. We'd rather run a Python code.
By the way, while I was doing this thing, some of you in the comments also mentioned you'd like to see some stats of the running process. Here you go. We are executing on one CPU, and we're using about 8 gigs of RAM for this process. Is it done yet? No, it's not done yet. I'll tell you when it's done. Come back later. This is taking so long. All right, while we're waiting for this, why is this taking so long? This is definitely more than 11 seconds at this point. I know you probably didn't experience this time in real time because we're editing this video out for you, but it's taking a while. We're now about 8 minutes in and still going. Well, folks, Python is a really slow language. It's really convenient, it's really easy to get started, but by itself, it's really freaking slow. That's why we have things like Numpy and other helper libraries which are not actually written in Python. They're actually written in Oh, it's done now. Okay. Numpy is actually written in C. So if we take a look at what is Numpy on numpy.org, you'll see that Numpy is the fundamental package for scientific computing in Python. It is a Python library that provides There's a lot of stuff in here. I'm not gonna read it all. I'm gonna jump over here to where it says, why is Numpy fast? So vectorization describes the absence of any explicit looping, indexing, and so on, blah, blah, blah. Basically, just behind the scenes, it's precompiled C code. Yes, code written in the C language, which is probably the fastest executing thing you can get because it's a very low level language. It's compiled, so it's going to be super optimized. It can be compiled for the platform you're actually running it on. So if you're on an M1 machine, for example, and your Numpy is not compiled for an ARM processor, it's not going to be as fast as if it were precompiled for the ARM processor. So that's something to watch out for as well. But no matter what, it's going to be faster than running the sort in Python and writing a different merge sort or whatever algorithm you're going to pick. It's going to be slower than executing precompiled C code. Guess what, folks? It is done. It took 801 seconds to finish TimSort, and 801 seconds is 13.35 minutes compared to 11 seconds using Numpy. So for those of you folks that have been asking me why using Numpy instead of using a Python written sort, this is why. Oh, and by the way, if you ever need to sort anything, any numbers in Python, use an external library, preferably one that's been precompiled in C. So are you a Python developer and you're wondering, oh, should I switch to JavaScript? I heard JavaScript is faster. Well, I'm going to be doing some tests on that too. Let me know in the comments if there's a particular test you want to know about, Python versus JavaScript. We're going to be seeing some differences there as well. And if you learned anything in this video, I'd appreciate a thumbs up. And if you want to see more videos like it, hit that subscribe button, make it gray. I'll see you next time.